All right, today we're putting on our detective hats. We're going to walk through a real-world debugging story, a modern-day mystery for anyone who's ever built or maintained a cloud application. We're going to solve a critical performance issue, and I'll show you how having the right clues can make all the difference.
So picture this. Your app is slow, and I mean painfully slow. The alerts are firing, the support tickets are flooding in, and all eyes are on you. You're looking at this huge, complex system with all these moving parts. The big question isn't just what's broken, it's where on earth do you even start looking?
For us, this whole story kicks off with that one alert. You know, the one that makes your heart sing a little? A critical transaction is completely timing out. We're talking about the checkout process here. So every second that ticks by, the business is losing money and users are getting frustrated. The clock is officially ticking.
Okay, so just like any good detective, our first move is to assess the crime scene. We've got to understand the blast radius of this thing. What's the actual impact? Who's being affected? And just how bad is it?
So, here's the rundown. The checkout process is failing for users, which of course is a direct hit to revenue. The system itself is a modern multi-service application running on Azure. But here's the first real clue, the thing that makes it tricky. Users are reporting that the timeouts are intermittent. And as we all know, intermittent issues are the absolute worst ones to hunt down.
Right, we know the stakes are high. Now it's time to map out our crime scene and start identifying the potential suspects. We need that 30,000-foot view of the entire transaction to see how everything fits together.
The flow is actually pretty straightforward. A user's request comes in and hits our web app on app service. That web app then turns around and calls an order API, which is running an Azure Kubernetes service, or AKS. And finally, that API needs to check inventory, so it queries our database. So there we have it, three main suspects: the web app, the order API, or the database. So how do we narrow it down from there? Well, we're not just going to start guessing. We pull out our #1 investigative tool, the application map in Application Insights. Seriously, you should think of this as a real-time map of the crime scene. It shows us how all our services are talking to each other, and more importantly, how long each of those conversations is taking.
And boom, just like that, the map gives us our first massive break in the case. It's not the web app. The map is basically screaming at us with a big glowing red line right between our order API and the inventory database. There's a huge delay right there. We've found our prime suspect. Now that we've isolated the problem area, it's time to pull out the magnifying glass. We're going from that high-level map down to the microscopic details of a single, slow transaction. We are officially on the hunt for the smoking gun. We grab a trace for one of the failed requests. The total time from the moment the user clicks the button to the timeout error is 3,100 milliseconds. That's over 3 seconds. In e-commerce, that might as well be an eternity. But where did all that time actually go?
And here it is. This is the key piece of evidence. As we dig into that trace, we see that out of those 3,100 milliseconds, a jaw-dropping 2,950 of them were spent waiting on that one call to the database. Almost the entire delay is happening in this one spot. We're so close.
And there it is, the smoking gun. Looking closer at the trace, we can see the database query isn't just running once. It's running, timing out after a second, then retrying, timing out again, and then retrying a third time. It was a misconfigured, overly aggressive retry policy in our API that was turning a single, simple query into this nearly 3-second nightmare. Case closed.
So we found the culprit, which is great, but the really interesting part of this whole story isn't just what we found, but how we were able to find it so quickly. Let's take a look at the techniques that made this whole investigation go so smoothly.
The secret sauce here is something called OpenTelemetry instrumentation. Now, that sounds fancy, but the idea is actually pretty simple. It's all about enriching our telemetry. We're not just logging that a database call happened. We're adding rich custom details, things like tags and properties that give us the full context, the whole story of what was happening at that exact moment.
And you can see here just what a massive difference this makes. A generic tag might tell you a user ID. Okay, that's fine. But an enriched tag tells you this is a premium tier customer. All of a sudden, you know to prioritize this fix. A generic tag might say a post request happened. An enriched tag tells you the exact query name that failed, get inventory. This is the difference between knowing something is wrong and knowing exactly what is wrong. So how can you build your systems so that solving these cases becomes routine instead of a panic? It really comes down to a few key principles, a kind of observability playbook.
It really all boils down to these 4 rules. First, standardize a core set of tags so that customer.tier means the same thing everywhere. Second, always correlate your traces with business context. Don't just track service names, track feature flags and user types. Third, and this one's huge, make instrumentation mandatory. No service gets deployed to production without it. And finally, treat your observability data as a product. It needs to be curated, it needs to be reliable, and it needs to be valuable.
And that leaves us with one last question to think about for your own systems. When you look at your logs and your traces, are they just telling you a story about what happened, or are they giving you the clues you need to understand why it happened? The answer to that question is going to determine whether your next outage is a multi-day mystery or a 5-minute fix.